Hello and thank you for joining me today as we begin our discussion on this new unit called Momentum and Collisions. When we look at what momentum is, how it's used, where we see it in life, all that sort of stuff. So today specifically we are going to talk about momentum and what's called an impulse. So let's get going. So for starters, you need to know momentum is defined as an object's mass times its velocity. Represented by the symbol P. I think it used to be a Greek letter rho. We'll go with P. Is a vector quantity. And so vector meaning includes both magnitude and direction. This velocity is speed in a direction, and so that's what we're going for there. Let's use this in a practice question, and then we'll continue on to talk about impulse. So an ostrich with a mass of 146 kilograms is running with a momentum of 2,480 kilogram meters per second to the right. What is the velocity of the ostrich? So we know the mass equals 146 kilograms. I know that momentum equals 2,480 kilograms times meters per second, right? So I know that P equals M times V. And so I can get V by itself by dividing both sides by M. So I know that V equals P over M, which means that 2,480 meters per second to the right divided by kilogram meters per second, divided by 146 kilograms, and I should end up with a final velocity of 16.99, which is going to round up. I'm going to get a velocity of 3 sig figs. It's going to round up to 17.0 meters per second to the right. That's momentum. All right, now we have momentum going in one direction. In order to change this, it takes a force and it takes time for that force to be exerted. We call this an impulse. So impulse is the product of the force and the time over which the force acts on an object. So impulse is the product of a force multiplied by the time over which the force acts. So we can create this what's called an impulse momentum theorem, which states that when a net force is applied to an object over a certain time interval, the force will cause a change in the object's momentum. So here's my impulse, force times my change in time, and that's going to change the object's momentum. So my change in momentum, my delta P, is going to be mvf minus mvi. So force times time equals your change in momentum. We're going to use this as well. And so one place that we see this, and where we see this a lot, is things like accidents and crashes and collisions. And so force is reduced when the time interval of an impact is increased. This is why in basketball, or in sports, I guess, proper techniques are so important. For example, baseball. When the batter hits the ball will experience a greater change of momentum if the batter keeps the bat in contact with the ball, for a longer time. So force times time, the longer the time that ball is in contact with the bat, the greater the change in momentum. And so that is what the goal is when you are batting, obviously. Other places you see this, you drop an egg, you do an egg toss. If you catch an egg with rock hard hands or hands like a plate, you're going to shatter your egg pretty quickly. On the flip side, if you catch and you release or pull back, you act kind of like a pillow. That force is reduced because the time is increased, and so the egg will typically stay in contact, stay in one piece. Same thing, soccer. When the ball is moving very fast, the player must exert a large force over a short time to change the ball's momentum and quickly bring the ball to a stop. So we're going to look at some of this. We'll do some practice right here. So we have a 1,400 kilogram car moving westward with a velocity of 15 meters per second. It collides with a utility pole. That's a terrible idea. And is brought to rest in 0.30 seconds. Find the force exerted on the car during the collision. Okay, so we know that we have the impulse momentum theorem. which is that force times my change in time is equal to momentum final minus momentum initial. So mvf minus mvi. Some things I know. I know my mass is 1,400 kilograms. I know my velocity initial is 15 meters per second. I know my velocity final is going to be 0 because I stopped. And I know that the time is 0.3 seconds. 30 seconds. So now I can plug numbers in here. I know that my force, we're looking for force, so I need to find F. I know that F times 0.30 seconds is equal to MV1, 1,400 kilograms, or MV final, sorry. So 1,400 kilograms times 0 minus 1,400 kilograms times 15 meters per second. Okay, so this is going to cancel out and be 0. So I'm going to get 0.30 seconds times F equals 15 times 1,400. So 1,400 times 15 is going to give me 21,000. So I'm going to erase that. So we have 21,000. And this is kilograms times meters per second. Let's try that again. Kilograms times meters per second. Okay, and so now I'm going to divide both sides by my 0.3. And I get a force equal to 70,000. And my units here are my kilograms meters per second divided by seconds, so kilogram meters per second squared, which is the same as a newton. So my force was 70,000 newtons, and because the car is going to the west, this is going to be to the east. That's going to be my force there. Alright, continuing on. So this is our example. Here's a different way to look at it. So this, seeing it this way makes better sense. We still get 70,000 newtons to the east as our answer. Alright, here is a practice question for you to try. So a 0.5 kilogram football is thrown with a velocity of 15 meters per second to the right. A stationary receiver catches the ball and brings it to rest in 0.020 seconds. What is the force exerted on the ball by the receiver? Pause this, try that question. I'll give you the answers on the next slide. So your answer should be 375 newtons to the left because the ball was going to the right and we're stopping it. One more time. Here's another practice question. Read through this. Try it yourself and then check yourself with your answer on the next page. And so your answer should come to 16 kilogram meters per second here. And then we can talk through how we got that if it's not making much sense. One more time. You have a high-speed train. I want to know the total stopping distance. Here we got to go a little bit farther. We got to try things a little bit different. So we have a total mass of 9.25 times 10 to the 5th kilograms traveling north at a speed of 220 kilometers per hour. Suppose it takes 16 seconds of constant acceleration for the train to come to rest at a stationary platform. Calculate the force acting on the train during this time, and what is the train stopping distance. So work through this one. I'll put your answers on the next slide. Alright, so your force should be 3.53 times 10 to the 6 newtons to the south, because we were going north initially. And then knowing that, we can calculate distance, which comes to be 488.88 meters to the north. Thank you for watching this video and working through these momentum questions with me. I look forward to continuing this discussion with you, and can't wait till next time.